All right, moving on to example number 3. This is very similar to the last several examples, the last two actually. We're looking at trying to find the first and second derivative of y, where we're given this equation xy plus y cubed is equal to 4. So we're going to use the following strategy. First, find dy dx using implicit differentiation, the same methods that we've been using, and then derive both sides again implicitly, and then finally plug the dy dx that you found using normal implicit differentiation. You plug that into your second derivative once you've found it. Okay, that's the general strategy with this. You do this, you'll get it right every time. Assuming your algebra is right, of course. So if you haven't given this one a shot yourself, give it a shot. If not, and you just want to see how this is done, that's cool too. So how do we derive this? First thing is that we have to worry about this x times y using the product rule. So we have x and y being multiplied, so we have to use product rule here as follows. So to derive this, we have the derivative of x, which is just 1. Then you leave the second one alone. Then you add on when you leave the first alone. And then you derive the second. That's y prime. Okay? Oops, I forgot to put parentheses around my y's, but that's okay. I think you get the point at this point, and hopefully you've gone through enough examples where you don't even need the parentheses anymore. If not, it's okay if you don't. All right, so now we need to derive the second term. So power rule mixed with chain rule, bring the 3 down, subtract 1 from the exponent. So you have 3y squared times the derivative of the inside, which is y prime. Okay, so that derives the second term. The third term on the right-hand side of this equation derives to 0. Okay, so now the idea is to get all the y prime stuff by itself. There's only one little bit of non-y prime stuff that we're going to move to the right-hand side. So namely, we're going to subtract away this 1y, or to subtract away y from both sides. So rewriting this gives us x y prime plus 3y squared times y prime is equal to minus y. So far so good? All right, so now what we need to do is get this y prime by itself. In order to do that, we notice that both these terms have a y prime in common, so we're going to factor that guy out. So we have y prime times x plus 3y squared. And then the right-hand side didn't change, so we're just going to rewrite that. All right. Final step, divide both sides by the parentheses. So you have y prime is equal to minus y over x plus 3y squared. All right, so that's the first derivative. That's equal to dy dx. Now we need to find the second derivative. So when you derive the left-hand side, that gives you y double prime. But now we need to use the quotient rule to handle the right-hand side of this. So I'm going to put a green dot here and a red dot here to indicate numerator and denominator as we handle both. So handle the numerator. How do we get the derivative of the numerator? Well, derivative of the numerator is just y prime, or minus y prime. Minus y prime. Then you multiply by the denominator, leaving it alone. Then you subtract when you have the numerator left alone, and then you derive the denominator implicitly. So the derivative of x is 1. The derivative of 3y squared is going to be 6y to the first times y prime. Okay, you can see that by putting some parentheses around this y and then using the chain rule. All right, so that handles the derivative of the denominator. Let's get rid of this first because we don't need it. All right. Then finally, when you're using quotient rule, you always have to remember to square the denominator. Very easy to lose points that way. Okay, so there we have it. We have implicitly derived both sides of this lovely equation above using the quotient rule. The final step of this process is to replace all of the y primes with this lovely thing you found earlier. So you're going to replace this and this with the big blue circle. Okay, let's give that a shot. So every place you see a y prime, you're going to place it with, I don't know why I erased that, this blue circle. So we have minus. I like to keep big things in boxes. Place that one with that. Then we have x plus 3y squared. And then we have minus, well, we have this minus y. So that'll become plus y. I guess I'll do that in green, just to make it clear that's what was happening. Then we have 1 plus 6y, and then we're going to replace this y prime with this minus y over x plus 3y squared. And then that was it. We just substituted in all of our y primes. And then finally, we have this lovely thing in the denominator that we just need to copy paste. All right, so that's that. One more small little simplification that we can do here is notice that we have a negative and a negative. Those cancel out. And moreover, interestingly enough, this and this cancel. So what does this buy us? A little bit in terms of simplification. So this gives us y plus y times this lovely quantity over here. Didn't change anything about this because I couldn't cancel anything. X plus 3y squared. And then the entire thing over x plus 3y squared squared. Is there a little bit more simplification that you can do here? Yes, you can factor out a y, and you can make this a little bit prettier, but on the whole, this is your final answer. You could have stopped right about here. If you would have gotten to that step without the cancellation, you would have been done with the problem. No need to simplify if you're not asked to. So that is the final answer for example number 3.